The other great new term I learned is...
It means AI that has a body,
right.
basically.
I used to just say AI with arms and legs, but this is a much
It's
cooler
embodied
way to say
AI. Yeah. The minute that you're asking a robot to now do thousands of tasks, there are like chances that they're going to have seen that in the training data is non-existent.
Traditionally, it was something called the VLM, a vision language model. And now we've got what's called a VLA model, vision language action, where the robots can not only figure out the answer to the question, but can then figure out a way to accomplish a task and, more importantly, react to environmental changes on its way to accomplishing that task. Really important concept. And what's really cool is these foundational models, of which Carolina's team is creating the Google Gemini foundation model for robotics that wants to be so foundational that it doesn't really matter. It's kind of platform agnostic.
Our mission is to build embodied AI responsibly to help people in the physical world. So we are focused on building that intelligence layer that powers general purpose robots. And we're not doing that in the traditional way in which robotics works today. It's more like a full end-to-end system that goes from pixels all the way to robot actions. So the same way that Gemini, for example, you can talk to it today and it will give you either text or image. Now we can get Gemini to actually move a robot and physically embody a robot and decide how to move in order to complete a task. Gemini Robotics is a VLA. So what we do is that we take a VLM like Gemini and then we adapt it to also predict actions. So now the same kind of reasoning that you have about the real world, about how do I reason about going from A to B, instead of just responding how to do that, it actually decides how to move the robot. So it's a different type of foundation model called a VLA. Yeah, I would say data is still a bottleneck for robotics. I think most people will acknowledge that. I think today our models still use teleoperated data in order to translate all this world understanding into actions. So that's a sure way to ensure that you can teach a model how to operate a new robot. But we're certainly always exploring many different data sources. So as you saw in my talk today, we're starting to explore world models. And we found it critical because as you start evaluating models on hundreds, thousands of different scenarios, it becomes really time consuming to even run the eval, let alone collect data for it.
Right.
So we're starting to leverage world models in order to evaluate many different scenarios. It's also super important for safety reasons. You don't want to be able to put really dangerous situations in front of the robot just to know whether it can handle it. So you can do this in a world model in a much safer place. Right? We have common sense safety.
Right.
So part of what we're working on is what we call semantic physical safety, which is essentially bringing to robots common sense when it comes to safety scenarios. So we have quite a lot of work in that area where we essentially are trying to extract from foundation models, because it's all there, like it's all on the human data. What are the common sense ways in which you should act in a new scenario? Yeah. So for example, if we ask the robot, hey, bring me a glass of water, it won't put it here at the edge of the table, even though we didn't specify. It knows that it doesn't make sense to put it there, it will bring it here.
Right.
And like that, there is millions of situations where things can go wrong. So that's one of the areas we work on. We also work on constitutional AI. This is actually the ability that you have to bring a constitution into a model. So
explain that.
Yeah, so it's super interesting. So the idea in constitutional AI is that there's a set of rules you can give the robot, which could be human generated or it could be data generated.
Okay.
And the robot has to follow that set of rules. We use this all.
So it's like a check against, like the Constitution is kind of.
It's exactly like that.
You got to make sure that it passes.
And it's one of the many ways in which we add a safety layer. And the Constitution can also be given in context. So you could say, in this context, I want to make sure that, for example, you don't go in that area, or you don't approach this type of situation. So it's one of the many ways in which you can bring some context into a robot. And I always find a moment where I'm surprised myself, because when these policies are very, very general, so people will come and ask all kinds of things I haven't thought of asking the robot. And it's just wonderful to see how deep the understanding is, how it can break things down into different steps. Also really amazed when he started doing really complex behavior like those belts, or those things are extremely hard and the team has spent years working on them. All of a sudden see a general model that can also do that.
Right.
It's really cool. I've also found it super delightful to see people speaking to the robot in their own language. So we bring it to conferences and people will come in and speak to it in like Japanese.
Right.
And the robot just responds, and just like the joy of people seeing that the robot understands all what they're saying is wonderful. And obviously I haven't tested it in Japanese, right?
Right.
But it's something that we inherit simply because Gemini supports all of these languages. Now the robots can understand all the languages. So
That's a great line, right? Life has more imagination than we do. You know, it's like you can't even think of these things. So that's really cool.
yeah,
Awesome. Thank you.
thank you.